Okay guys, in the last video we reached to this point. We replace omega t by x, and once we put this substitution, we get the output current, which is equal to Im sine of x if x is less than pi and greater than 0, and its value is 0 if x is less than 2 pi and greater than pi. Now the Fourier series is I of x is equal to a naught divided by 2 plus sum started over n, which started from 1 to infinity, a n cos nx plus sum over n started from 1 up to infinity, bn sin nx. This is, let's suppose, equation number 2. I call it equation number 2, yes. And this is equation number 1. Now we have to calculate this unknown quantity a naught, a n and b n. And we know that where a naught is equal to 1 over pi integral of 0 to 2 pi. The period is now 0 to 2 pi, because from 0 to 2 pi we have the period. We get the same situation after 2 pi. Like 0 to 2 pi we have half cycle, no signal. Then after 2 pi we have half cycle and no signal, which are up to 4 pi. So the period is 2 pi. So the limit of integration are from 0 to 2 pi. And we have Ix dx, and an is equal to 1 over pi integral from 0 to 2 pi, and we have I of x cos nx dx, and we have bn, which is equal to 1 over pi integral from 0 to 2 pi bn sin nx dx. This is the Fourier series, and these are the coefficients of Fourier series. Now we have to first calculate a naught. As a naught is equal to 1 over pi integral from 0 to 2 pi I of x, the output current, and we have dx. Now this will become equal to 1 over pi. I integrate, I take two parts of this integral. One is from 0 to pi and the other one is from 0 pi to 2 pi. Like from 0 to pi, the first part, plus from pi to 2 pi the second part. Now I of x value in 0 to pi is Im sin x. And we have dx plus here from 0 to pi to 2 pi the value of output current is 0 times dx. So it means that we have 1 over pi and we have integral of 0 to pi Im sin x dx, because this is already become 0. So this will become Im over pi integral from 0 to pi sin x dx. If we integrate this function, I will get Im over pi, and here we have minus cos of x, and the limit are from 0 to pi, and from this I will get 2. So we have 2 im over pi. This is the value of a naught. Next we move to calculate the value of an, and then we will calculate the value of bn. The value of an is an value is 1 over pi integral from 0 to 2 pi I of x cos nx dx. So again I convert this integral into two parts, 0 to pi and then from pi to 2 pi. So here the value of ix from 0 to 2 pi is im sin x, and then we have cos nx dx, and here we have 0, the value of I, and then we have cos nx dx. Now this will automatically become 0. So we left only with this one, which is im constant, which I keep outside of the integral, and we have pi here, and then we have integral from 0 to pi sin x cos nx dx. To solve this integral, it's a lengthy equation, so I will keep it as a homework. Do it by yourself. So I will just write the final result. Here we have im over pi, and from this I will get the value of 2 over 1 minus n square for n is equal to even number. Even. If n is even, then we have this. If n is odd, then this will gone. Its value is 0. So we have this en. And similarly, if we calculate bn by using the same procedure, we get bn is equal to im over 2. And this is only for one value of n, for n is equal to 1, otherwise its value is 0. Now if I call this equation number 3 is this one, this is equation number 2, so this is equation number 3, and here we have equation 4 and 5. This is 4 and this is 5. Now using equation 3, 4 and 5 in equation 1, in equation 2, sorry, we have using equation 3, 4, 3, 4 and 5 in equation 2, we have I is equal to I of x, yes, I is a function of x, is equal to a naught over 2. A naught is 2im over pi into 2, so we have a 2 here, because if you look at here, we have a naught over 2, and a naught value is this one, 2im over pi. So if I put it here, then we have 2 in the numerator and 2 in the denominator, so this value. And similarly, then we have this summation over n, and started from 1 to infinity, an cos nx. So here I will replace this value an. So we have this summation over n, but for n we have now started from even number. Okay, n is an even number, started from first even number till infinity. And then we have an, which is im over pi. An is this one. And then we have 2 over 1 minus n square. And then we have cos of nx. And then we have this term, which is this one, bn. And for bn I will replace n. The summation is from n started from 1 up to infinity. But for bn we get bn only for n is equal to 1, otherwise it's 0, so we don't need summation here. So we will just write, instead of bn I will write im over 2, and we have sin x, sin nx, but n is equal to 1, so I just call it sin x. So this is the final expression now. I will simplify it a little bit more. I of x is equal to 2 cancel with 2, so I left with im over pi, plus I bring this side to this here, im over 2 sin x, plus sum over n, which started from first even number till infinity, and n is always even. We have 2im over pi to 1 over 1 minus n square. I can keep it outside this factor, outside of the summation. We have im over pi plus im over 2 sin x plus 2im over pi sum over n. N is always an even number. Okay, 1 over 1 minus n square. Now we already put a supposition that we replace omega t by x. Now I put it again back in above equation. So here we have iota, the current I, which is a function of time now, which is equal to im over pi plus im over 2 sine, instead of x I will replace it by omega t, plus 2im over pi, and we have this summation. N is an even number, started from first even to infinity, 1 over 1 minus n square. This is the final expression, and I call it equation number 6. In the next video I will proceed further by using this equation. Thank you.